Hello everyone, this is group 5. Our topic is knapsack problem. And the classical knapsack problem is one of the most studied NP-hard combinationary problems in recent decades. But people's research is often limited to knapsack problem. We study different knapsack capacity and the population size by changing conditions and study different algorithms. So as we start with algorithm is more suitable for solving knapsack problem in different cases. So as to extend to a single optimization problem, this research method is also applicable to the solution and the research of all other optimization problems. So this is our Google site, and you can see this first page is our PowerPoint slide here. And let me introduce my team members. And our team member first is Neil. It's very handsome, and Chakong is Katong, and Wang Liang, and Li Dongyang is me, and Xu Junqi is a beautiful girl. And let's move on to the introduction. The introduction is Wang Liang's part, and let's invite Wang Liang.
Okay. First of all, I will introduce what's the knapsack problem. Given a set of items, each item has its own weight and price. Within the limited total weight, how do we choose to make the total price of the item the highest? There are 8 types of knapsack problems, such as 0-1 knapsack problem, complete knapsack problem, multiple mixed 3 kind of knapsack problem, 2-dimension closed knapsack problem, grouped knapsack problem, and dependent knapsack problem. Also have a total number of solutions for knapsack problem. For the problem statement, the 0-1 knapsack problem belongs to the categories of combinational optimization problems. Combinational optimization problems typically involves the selection of an optimal solution from the fitness set of solutions. Exhaustive search for these problems is usually not suitable, as it may be computationally expensive. So we choose to the genetic algorithm. It has good global search ability and can quickly search for all solutions in the solution space without falling into the trap of a rapid descent of a local optimal solution. And using its inherent parallelism, it can easily perform distributed computing to speed up the solution. However, the local search ability of the genetic algorithm is poor, so that the simple genetic algorithm is time-consuming and the search efficiency is low in the latest stage of evolution. In practical applications, genetic algorithms are prone to premature convergence problems. It has always been a difficult problem to solve in a genetic algorithm, which selection method should be adopted to keep the excellent individuals and maintain the diversity of the population. So the main objective is to compare the running time and the reward between different types of genetic algorithm and particle swarm optimization. Pass to Mitch.
Okay, thanks Wang Liang. And the next part is review. Let's invite Junqi, and I will stop sharing my screen. And Junqi, please.
Okay. Okay. We have searched for a total of 10 papers. From 1 to 4 were on the GA algorithm, and from 5 to 6 on the particle swarm optimization algorithm. In the first paper, firstly studied the advantages and the disadvantages of the individual encoding methods for solving 0-1 KP using GA and the planetary function method, and the restoration method for handling invisible solutions of 0-1 KP, and point out that the 0-1 vector encoding of the individual of GA is more effective than the natural number encoding, and the restoration method gives better results than the planetary function method for handling invisible solution of 0-1 KP. Since then, The 0-1 vector encoding method has been generally used in solving 0-1 keep using EA. In the paper 2, Lim used monogamous pairs to improve the GA method for generating offspring individual, and based on the Peneley function method to calculate the fitness of the individual. A new GA algorithm was developed to solve 0-1 keep MOPGA. In the first paper, the paper proposed the GA use parallel GA to produce morphisms of a superior generation. Each parallel algorithm has a gene size of population and will be continued until best answers can be improved. The PGA has improved the performance and probability of the convergence towards the best answer, and the runtime is reduced. And this paper is also our anchor paper, on the basis of which we improved the algorithms and algorithm and compared it with particle swarm optimization algorithms. The paper 4 used several algorithms to solve single problems, 0-1 knapsack problem, grid algorithms, dynamic programming, branch and bound algorithms, and GA. In the conclusion, generic algorithms achieve higher effects in face of how near the impact belongs to the junior authentic ones. In addition to GA, we have also PSO, ACO, SF, LA, and MA, and OMBO. Okay, that's all. Next, Dongyang and Guo Hong will share our algorithms.
Yes, thanks, Junqi, and welcome, Guo Hong.
Yeah, so basically in this project, right, we are going to examine 5 evolutionary computing algorithms. Yeah, so the first one is standard genetic algorithm. So basically, genetic algorithm is a computational model of biological evolution process which simulates the natural selection and genetic mechanism of Darwin's biological evolution theory. So it is basically a method to search the optimal solution by simulating the natural evolution process. Yeah, so I'm going to talk briefly on what are the general steps of this standard genetic algorithm. So first, the algorithm will evaluate the fitness of the individual corresponding to each chromosomes. Then, according to the principle that the higher the fitness, the greater the selection probability, 2 individuals will be selected from a population as the parent and mother. So the third step is it will take chromosomes from both parents and cross them to produce offspring. And fourth, the chromosome variation of offspring. And then the 5th step is you repeat steps 2, 3, and 4 until a new population is generated. Yeah, so as you can see, this is basically a working flow of the standard genetic algorithm. Yeah, so there are basically a few advantages of using this algorithm. So first, it is very fast. It's fast and it's a fast and random search independent of the problem domain. And second, the search starts from the group and has potential parallelism. Third, it is inspired by the evaluation function and the process is simple. Fourth, the probability mechanism is used for iteration, which is random. And then 5th, it is scalable and easy to combine with other algorithms. However, there are also a few disadvantages of this algorithm. So first, the implementation is quite complex. So because basically the problem needs to be encoded, and after finding the optimal solution, the problem needs to be decoded. Yeah, so second is it has many parameters, such as crossover rate and mutation rate, and the selection of these parameters will seriously affect the quality of solution. Yeah, so and then third is the feedback information of the network is not used in time, so the search speed of the algorithm is relatively slow and takes more training time to obtain a more accurate solution. And then fourth, the algorithm actually has a certain dependence on the selection of the initial population and can be improved in combination with some heuristic algorithms. And the last one is the potential ability of the parallel mechanism has not been fully utilized. Yeah, so our second algorithm is restart-based genetic algorithm. So this implementation is basically identical to the traditional approach that I mentioned just now, with the only difference that during the convergence point, the point when the algorithm fails to improve the quality of the winner genome. The advantage of this algorithm is that it actually introduces a new random population when the threshold value is not achieved, with the winner from previous generation continue in the new cycle. Yeah, so basically the third algorithm that we are going to use is called island genetic algorithm, where this algorithm is actually a parallel version of the traditional genetic algorithm with k separate generations performing k separate genetic algorithms. However, the major highlight of this approach is that they share the best answers together. Yeah, so the advantage of this algorithm is, other than speed, this version offers a stochasticity during the crossover and mutation operations. Yeah, so I'll pass to Li Dongyang.
Okay, thanks, Go Hong. And let me share my screen. And now I will introduce modified GA. A modified genetic algorithm is we learned from the paper and propose a hybrid version of the restart base and the island genetic algorithm in order to overcome the limitations. The MGA runs numbers of genetic algorithm in parallel over specified search spaces. The winner of each sub-genetic algorithm are added to a superior population. An outer genetic algorithm is then deployed over the superior population to obtain the overall winner. And you can see the visualization of the MGA. The first is no mark pictures, and the second we can see the curve of the graph is changed very irregularly, and there will be the lowest point and the highest point. So here we just mark the lowest point here, and we choose them to run in a modified genetic algorithm. There are multiple local minima in the figure above, which pose a threat to the traditional methods. In order to solve this problem, we first divide the x-axis of the graph into m subsets, and each subset has a subpopulation size. Then we run m parallel genetic algorithm on each subset. This gives us the local minimum of each m subset. Then we use the m winners and our population and run external genetic algorithm on the superior population to find the global medium. It's a very good effect to make the result good. And for the steps in modified genetic algorithm, it's followed the basic genetic algorithm. It has the initialization, it has a selection. You can see it from the picture, and it has a crossover, and has the mutation, and has the termination. If it's satisfied the end task, so we end the cycle. And compare the modified version with the traditional algorithm. We can note the following two paragraph. The diagrams shows the step of traditional GA algorithm and the steps of the new improved GA algorithm is named as a modified genetic algorithm. There are two differences between the improved GA algorithm and the traditional GA algorithm. We can say here, traditional genetic algorithm has 5 steps, and the modified algorithm is first run parallel threads to the reduce the time complexity, you can see here. And second, each thread works on a subset of the search space, which helps to avoid convergence at the local optimum. So the advantages of the modified genetic algorithm, first is the high time complexity is solved, and 2 is get rid of the local optimization. But the disadvantage is first, the complexity of the algorithm is improved, and 2 is need more running spaces. And for the particle swarm optimization. The particle swarm optimization algorithm is a very magical algorithm in the field of computer intelligence. It is a biological heuristic method which is equivalent to optimization algorithm in a swarm intelligence. At present, there are many similar algorithm like on the colony optimization, particle swarm optimization, and the bacterial functional optimization, and the suffered frog linear optimization, and the artificial being colony optimization. Although these are common algorithms, there are some swarm intelligence algorithms that are not very common and widely used, such as the Kriller swarm algorithm, Firefly algorithm, Kuka algorithm, and Magic Bat algorithm, and so on. For example, for the particles, for the PSO, take a simple example here. Now have a group of birds and looking for the food. And their food in this area, only some of them know where is the food. And in this way, all birds in the group will move towards to the position of the bird close to the food. In this way, the position of the bird will change. So it can be concluded from this example that the 2 factors affecting the changing of the bird motion states. The first is the location of the bird nearest to the food, and the second is reach the nearest place to the food before the bird reaches the final food. And the dynamical graph displays of the particle swarm optimization algorithm, you can see that finally they will get the most good result. And the overall particle swarm optimization algorithm steps, there have 6 steps. First, we create a uniformly distributed particle swarm in the position region X. And the second, we evaluate the place of each particle according to our objective function. And then if the current position of the particle is due to its previous best position, we will update its position. And for the third, find the best particle and its position. And the fourth is update the speed of the particles and five, move the particle to its new position. And six, skip step two and then repeat the algorithm until the stop criteria are met. Generally finding the best position, and you can see the big code of the PSO. And for the advantage and disadvantage, for the advantage, the PSO algorithm does not have the crossover and the mutation operations like a traditional genetic algorithm. It relies on the speed of the particles to complete the search and will only select the optimal particles in each real evolution to pass the information to other particles. So the search speed is very fast. And the second is a PSO algorithm has memory. So we can find that in memory. And the third is PSO algorithm needs less parameters to be adjusted. So it's very simply. And the PSO algorithm uses a real number for coding, which is directly determined by the solution of the problem. And the number of variables of the solution of the problem is directly taken as the dimension of the particles. And the disadvantage is also the PSO algorithm lacks the dynamic adjustment mechanism of speed, which is either fall into the local optimization. And the second is it can be effectively solve the problems of discrete and combination optimization. And the third is some problems that are not described in the direct coordinate system cannot be solved effectively, such as some solving problems about the motion law of the energy field or particle in the field. And fourth is there are some defects and uncertainties in parameter control. For different problems, how to select appropriate parameters to achieve the most effective is a problem which needs a lot of research and time. And the next, we move on to the implementation, which is Neil's part. And welcome, Neil.
All right, hi everyone. All right, I'm going to share my screen. All right, so yeah, about the implementations, as you can see, there's a code available at this GitHub link. Yeah, let's open this GitHub. And here are all the available code and the dataset. Values.zip is the dataset, and the restart GA, the particle swarm, island GA, yeah, everything is in here, right? Let's go to the codes. Like, since this is a knapsack problem and it's a binary problem, therefore traditional real world problem genetic algorithm does not work well. So therefore we have to recode. Yeah, here's our code. Let's skip all the important concurrency. So let's start with our main problem here. So the dataset are available at this values.1. So we can see from here, that's 10, 20, 15, 10, 15, 20, 25, and 30. So, and this is the capacity of it. So let's run one by one, since we only got 4 datasets. Sorry, to activate Python library. Right, now code is running. As you can see, it's like taking all your sequence, and then I record the time taken for each of the algorithm to run finish. And this is the rewards. The rewards is the fitness value the algorithm has obtained. So, right, is ready, run all 4. And here's the values will be saved in this .text file. And the rewards also will be saved for each of the iterations. It's the same as the restart GA. Let's go to restart GA. It works the same behavior because it's just the same problem with different algorithms. So we just plug and play. And this is our algorithm data, our mutation schemes. It's actually uniform and flip mutation because our mutation value cannot be real world problem or other things. So we only can flip the bit. So here's the bit. You can see the sequence. The item we pick is 1. The item we don't pick is 0. Right. So you can see it also outload the same thing. And the restart GA has a lesser time, as you can see, and has a lesser capacity. And this the amount of the reward. Now let's go towards the island G. All right. Island. And you can run and see this the profit, and this is sequence generated, and it's similar to the modified genetic algorithm. And here we get the profit sequence. I mean the profit value, the rewards, the sequence of the item they get, and here's the capacity they use. All right, let's go back to for the last one, the PSO algorithm. I have rewrite it in here instead of using the py file, I use the Jupyter file. As you can see in here, we already run for each of them. This one is when our number of iterations 30. Yeah, so we set, this is 25. So you have 25 items here, as you can see. So let's run one time. Completed, and here is this the rewards, and this the item they get, and this the time. And I already record one by one down there for the particle sort optimization problem. Let's go back to result where we tabulate it. So in the result section, we tabulate one by one the genetic algorithm, the restart genetic algorithm, the island genetic algorithm, the modified genetic algorithm, and the binary particle swarm optimization. Since from the graph we can see that at the higher number of the more items the algorithm needs to choose to optimize, genetic algorithm takes the most time, and the binary particle swarm optimization takes the least time, as you can see from here. Then the restart GA takes a bit slightly lower, the modified GA gets a bit higher. This will be the top 3 results where the time is less. Since we can see on the right hand side, we can see the graph. 1, 2, 3, 4, 5. 5 of them. Everyone get the same average reward. As you can see, the rewards they obtain is 4,000 something, 6,000 something. Everyone gets almost the same thing. And in here, we can slightly see that the mock GA slightly lower, but everyone else is the same thing. So conclusion is most of them has can achieve similar rewards, but binary particle swarm optimization get the least time. All right, that's all from our side. Yeah. So who's next?
Thanks, Neil. And the next day is the reflection part of Go Home. Work on
Okay,
Go
reflection still, no more time already. We're long already. No need on reflection, right?
Okay.
Okay, lor. Yeah, so this is the end of our presentation. Thank you.
Thanks, everyone.
Thank you.